This is Stan. Stan is about to have a very bad day.
Whoa, hey, give that back.
That's not a hole in the ground. That's a black hole. And Stan just made a huge mistake. Let's pause the chaos for a second and explain what Stan is dealing with. A black hole forms when a massive star runs out of fuel and collapses in on itself. All that mass gets crushed into a single, infinitely small point.
A point? Like a dot?
Smaller. Physicists call it a singularity. All the mass of a star, sometimes many times the size of our sun, squeezed into basically nothing.
That seems aggressively compact.
It is. And because all that mass is concentrated in one spot, gravity around it becomes so strong that nothing, not light, not matter, not Stan, can escape past a certain point. That boundary is called the event horizon. Cross it, and there's no coming back.
Good thing I'm standing pretty far. That was not there a second ago.
Here's the part that gets uncomfortable for Stan specifically. As you fall toward a black hole, the gravity pulling on the part of you closest to it is way stronger than the gravity pulling on the part farther away.
Wait.
Scientists actually call this spaghettification. Your body gets stretched into a long, thin noodle shape as you fall in.
I would like to lodge a complaint.
Don't worry, Stan isn't actually falling in yet. This is just a preview. For a black hole the size of the ones formed from dying stars, spaghettification would happen long before you even reached the event horizon.
I've decided I don't like this video.
Here's where things stop being just dangerous and start being genuinely mind-bending. If Stan got close enough to the event horizon, and you were watching from a safe distance, something strange would happen. From your point of view, Stan would appear to slow down, and down, and down, until he looked almost frozen in place, forever inching toward the edge but never quite crossing it.
But I'd feel normal the whole time?
Exactly. This is called gravitational time dilation, and it was predicted by Albert Einstein's theory of general relativity back in 1915. The stronger the gravity, the slower time passes relative to someone farther away. It's not just theory either. We've measured this effect with real clocks. In 1976, physicist Robert Vessot sent an atomic clock into space on a project called Gravity Probe A, and it ran faster than an identical clock on Earth, exactly as Einstein predicted.
So the closer something is to a black hole,
the slower time moves for it from an outside observer's perspective. Get close enough, and you'd watch Stan basically freeze at the edge forever, even though to Stan, he'd just calmly fall in.
forever sounds long. I'm gonna go.
So what happens if Stan keeps going and actually crosses the event horizon?
I wasn't going to.
Honestly, we don't fully know. Physicist Stephen Hawking spent much of his career studying exactly this question, and even he admitted that the math breaks down once you reach the singularity itself. Our best physics, the equations that explain literally everything else in the universe, simply stop giving useful answers at that point. It's one of the biggest unsolved mysteries in all of science.
So nobody actually knows what's down there?
Nobody. Not for certain. Some physicists think it leads to a point of infinite density. Others propose wild ideas like wormholes to other parts of the universe, though there's no solid evidence for that. The honest answer is, we don't know yet, and that's part of what makes black holes so fascinating.
Can we revisit the wormhole to somewhere nicer theory?
Luckily for Stan, he's still safely outside the event horizon, which means there's still time to get out of here. In real life, nothing close enough to cross that boundary can ever escape, not even light, which is the fastest thing in the universe. That's actually how black holes got their name. Light goes in, and none comes back out.
Note to self, don't poke unidentified swirling dots.
Black holes aren't really holes at all. They're some of the densest, strangest objects in the entire universe. Places where gravity wins so completely that even our best science runs out of answers. And somewhere out there, in the real universe, there are objects like this, silent, invisible, and waiting. Stan got lucky today.
Next time I'm bringing a longer stick.